Hey guys, please let me know if the sound and everything is alright. We're going to start in a while. Your video is chopped from the top. You mean the Unity? Oh, you mean my video. Give me a moment. Is it fine now? Oh shit, it's too no. This should be fine. Alright. Give me one moment, guys.
Yes, sir. Oh, hello. Oh, okay. Yeah, it will. Okay. Good night.
Hi Oblivion, what are we doing today? Shades and FX. Yeah. Hi Graphy. Long time. Yeah, it's been a while. I think it's been 2 weeks, maybe. So today, the plan is to work on some. We are hearing some other audio. Give me a moment. Let me see. You are unable to hear my audio, or are you hearing something else? Just. Is the audio fine now, guys? Please let me know. And I'm sorry for all the technical difficulties. I'm not a pro in streaming. I mean, while you were in call. Yeah. So it's also like some of the studio folks are working. Like they've almost closed for the week. So it's like I'm managing that as well. So I was just speaking to the animator, and he was closing for the week basically because it's a weekend. So yeah. Any case, let's start. So today the plan is to work on, or not work, at least, yeah, work on some shaders and VFX stuff. So I'm gonna turn this off now. So let's make a new scene. VFX. Let's create a new scene for the stream. Is there anything in particular that you guys would like to see when I'm talking about is overlapping your video? Yeah, that's the thing. Now it should not. Hopefully. Is there anything in particular that you guys would like to see when it comes to uh, technical art and VFX, or should I just start with whatever I think is the most appropriate? Let me know. In the meanwhile, I'm just setting up a scene so that we can start with it. And I'll be streaming until 9:30, 9:45 today. So yeah, after that I'll close the stream. And as always, if you have any queries or questions, just drop it in the chat, and I'll be able to solve those. Ground floor, where is that material? Prototype. Where is that material for the ground that I always use? Yeah, it's this one, right? Yep. All right. So for creating shaders, right? I generally use Amplify Shader Editor because it's just easy for me, right? I'm like, it's easy as in it's convenient because you get this instant feedback uh, on when you create the shaders. Like this is what I use. I don't use the Unity, so I use this editor to create shader basically. And instead of Unity's inbuilt, I don't remember what's the name of that Unity uses. I forgot that. But I use this Amplify Shader Editor. It's a paid plugin, but I also know how to write shader code in HLSL, which is Unity's you know shader language. So I can use that as well. But for today, I might be using Amplify Shader Editor, and you can just replicate it in whichever node base this thing that you guys are using, or I can even write the shader code. So let me know what you want to see. Do you want me to directly write the shader code in the code itself, or do you want me to use this Amplify Shader Editor? It's up to you guys basically. So yeah, let's okay. So I'm going to create a fire effect, basically a fire effect as in a flame effect, just to get things started, and from there we can take it forward accordingly, basically, because we need a fire for the lamp that we have in the game, right? So I'll show you one of the lamp assets that the team has created. So this is the temple lamp, and we need some kind of flame for this lamp. So let's create that. I think that'll be cool. So in this way I can clearly show you how I create effects and how I create shaders and things like that. So let me just put temple of flame effects. Shaders. To the stream. Flame. All right. So, right, how many of you in this who's watching the stream have worked on VFX or have worked on uh, you know shaders and things like that? Please let me know so that I get a sense of uh, how much you guys are. Hi, digital art. Hello, welcome to the stream. All right, so let's start. Let's add a color node. or let's make a unlit shader. We'll use a standard shader itself, but we'll make it transparent and transparent, right? And then we'll create a material. I am a noob in shaders, no worries. All right, so just to give a okay, so this you guys should not see that screenshot since it's still in development, but let me just give you guys a brief overview of what shaders are, right? So that you get a because so basically what shaders do is that it's actually a part of the pipeline when you're working on in 3D or 2D basically, and shaders are a way to talk to the graphic card. So that's why we use shaders, right? So the way it works, just to give you the theory behind it. So let's say because in the past, like before graphic cards came into the picture, I have made a few shaders before, but I've never worked with HLSL in Unity. Oh, all right. Yeah, I mostly in my free time I generally work in GLSL because I use a lot of OpenGL. But because Unity uses HLSL, I'm assuming under the hood it uses DirectX, Vulkan, or OpenGL based on whatever is compatible based on your system. But it uses HLSL and it uses Unity HLSL basically. It's a Unity's shading language, which then I think it parses or converts into appropriate shader code based on the based on the whatever system your game is running on. But that being said, let me just give you a brief overview of what shaders are and how it um, comes into the picture, right? So generally what happens is that you have your vertexes in Unity game engine. So let's say this is one chord and this is one chord, right? And this is a vertex 0, vertex 1, and vertex 2, or vertex 2 and then 3. So these are the four vertexes for a chord, right? So what generally, and this is called a pipeline basically. So what happens is that this is the vertex stage. So let's say you want to draw a chord on the screen, right? You want to draw some kind of a character like a Mario or something on the screen, right? And you're using the the latest tech which uses graphic card. So the ideal way to go about doing is that you will draw a chord like this, right? And this chord will have vertex 0, 1, 2, and 3. It's called the winding order. This is generally how vertexes are aligned. It's always in the winding order. And then what will happen to this vertex is that it will be sent to the GPU from your CPU. It will be loaded by the GPU, and in order to render the fragments in this code, that is what the shader does basically. The shader is the code that runs in your GPU basically, and it tells the GPU to render whatever you want in your code basically. So regardless of what it is, it can be a character, it can be whatever you want basically. And it's GPUs are quite fast because there are a lot of cores in it, and it all happens concurrently or parallelly, rather than like in CPU, which happens in cycles. So it's much more faster and it's much more efficient as well if you do that. So but primarily shaders work, or shader is a language which is used to run in your GPU, if that makes sense. Yeah, yeah. While fragment shaders handle the colors and overall visuals. That's exactly. But because HLSL, I did not want to bring vertex shaders and this what do you call fragment shader in HLSL, because you don't have that. You just write one HLSL shader in Unity, and then that takes care of your vertex data as well as your fragment data basically. So that is the high level uh, theory of what a shader code does. And I'm using this kind of a node based shader editor to build the shader. But what we can also do, I'll just give you a brief overview of that as well. So if you go in Unity, if you go here, and if you just create a standard, let's say we create a standard unlit shader. So this is what a test shader code, a test shader code So this is how a shader code looks like, right? So at least this is what the Unity's shader code looks like, basically. So this is your vertex data, and this is your vertex data, and this is your fragment data, basically. So and this is completely different than whatever code that you write in C# or that you use for scripting inside Unity, basically. So that being said, so just to give you a brief primer of what this does, if you don't understand this, I'll just give you again an overview of it. So this is basically your vertex position. So your so lot of things. So it's a Unity is a very abstracted engine, right? That's why you're using a game engine, because a lot of things are abstracted for you, basically. So technically, when I create a chord over here, there are a bunch of things that are happening under the scene, right? There's the engine itself creates a data for this mesh to be drawn. It creates a vertex data, it creates a fragment data, and then we as the users of Unity engine use that and then apply the textures and everything else in the engine, basically. So what Unity has done is that they have abstracted all that information and give it to us in a very simple manner, basically. So this app data struct, what it does is that it takes, what you see over here is the vertex position and the UV texture coordinate, basically. And we don't want to use the fog coordinate over here, and we don't want to use this as well. So let's just, and this is just boilerplate, and if you want I can take you through line by line with this as well. I don't know if that it will be that useful in this stream, but I'll do that. So this is basically the path for the shader. So we can put whatever path we want. Let's say we'll put stream and test shader code, and if I create a material over here now, see it, material, and if I go here, you'll see stream, and this is our test shader code. So this is basically that, and these are the properties that we want to use. So this is the variable, the main text is the variable that will be used in this shader, and the texture is the one that will be exposed in the material editor, basically. So let's just call this what we can call it whatever we want, does not matter. So let's just call it for now main texture. And if you save this, so you can see here it's written as main, it's shown as main texture over here. So if I just do it as main text, it will be shown as main text over here. So this is basically just for the user's sake, and this is the actual code. And generally you should, there are a lot of things, the easiest way to get acclimated with all of this is just look at the documentation, basically. So if you introduction to writing shaders in, because a lot of things over here, and yeah, Shader Lab is I think Shader Lab is the language that Unity uses, its own shader language, which we're using, basically, which is not exactly HLSL. It's even abstracted than HLSL, basically. But that being said, a lot of things over here, you should read the documentation, because a lot of keywords that you can use that Unity exposes. So for example, if you use main text, this is something that Unity uses inside in its own default materials and things like that. So if you're creating a custom UI, and if you put main text, you can use the image component in Unity, and then you can manipulate a lot of different stuff. Just understand that there are a lot of keywords that are there, basically, that you can use, like this main text, to hook it with Unity's component, basically. All right. So that is property. So let's say I want some kind of a float exposed over here. I can just go here and put like some value. So let's say color strength, right? And then I can put color strength and float. I think it's float. And this is something that you have to either look at the documentation, or there is no, it's basically either it automatically is in your brain because you have been working on it for so long, or you just get used to it. So if you want to declare a variable, you can just write it Unity shader variable, how to declare or something like that. I mean, this is the best way to learn, right? So built-in shader variable. So you can see different, these are just built-in variables, but what we can do is that, I'm just doing it so that I can show you, like, if you are stuck, how you can do it basically in Unity. Shader lab. Yeah. So where is the documentation for that? There was a document. Yeah, this is the documentation for that. So this is how the syntax works for the material property declaration. And new learners often don't read doc enough, even though it can make life so much easier. That's true. I mean, I love to read documentation, so I generally don't like to look at the Google or the Chat GPT or all that. I like to read the documentation first, get myself acclimated with the documentation, and then if I'm in a hurry, look at all the other stuff, because most of the times documentation takes care of a lot of different stuff. So you can see how you can declare float over here, right? So it's the name of the variable, and then the display name, float, and then the number. So let's just do that. So it's basically float is equal to 0.5. So this is the default value. So let's just put it as 0.1. Strength spelling is wrong. So this is how you and how you can declare a variable. You can do all sorts of variable declaration. So you can create an int as well. I think int is capital. Yeah, right. Int is, but this is legacy. So you can use integer. And I believe some integer. Let's call this integer for now. I believe we should have an integer now. So this is how you can declare integer. You can do all sorts of fancy stuff as well, like having a range. I don't remember how. I think range is something like this, maybe. Let me just yeah. So now you have a slider over here which can increase and decrease based on a certain range. And yeah, so that's how you can declare properties. And then you have subshader, and subshader is nothing but inside subshader there are different sections. So you have tags, which is where you kind of define what the render type is. So there are different render types, right? There is opaque shader, there is transparent shader that you can build. So opaque shaders are nothing but they're completely opaque. And then you have transparent shader, you have overlay. I can again open the documentation for that. So render type shader lab Unity. Again, no one can, it's highly important that you look at the documentation and understand how these work, because otherwise you'll just be looking at tutorials all your time working basically. So it's always important that you go back and just understand at least high level on how different syntaxes and things work. So wait, let me see where the render type is. Give me one moment. Render type Unity. Yeah. So where is the second? I think classes, tags. Yeah, and also I don't really blame people for not looking at the documentation, because sometimes it can also be like a little difficult to navigate through the documentation. So So these are the different render types that you have. You have opaque, you have transparent cutout, background, overlay, tree opaque, tree transparent, billboard, grass billboard. So opaque is basically, shaders which are like completely opaque. So think of it mm, like there's no transparency in it. If you don't need any transparency, right, that's when you would use that. And if you want something transparent, then you use the transparent. Now transparent cutout is unique. It only supports 0 or 1. So wherever there is 0 value in alpha, it will completely cut it out. The best part about transparent cutout is that it's cheaper than transparent, basically, because it only has that true or false situation going on with it. So that's transparent cutout. And then you can use background, which is rendered at the very at the very far end, basically. So for example, like skyboxes and things like that, you can use the background overlay. If you are using UI, so it has to be rendered on the at the very front, basically. So it's rendered at very. So the way rendering works, rendering order, there's something called rendering order, right? So, and I think Painter's algorithm, I don't know what Unity uses. So there is a way that certain things are rendered in your viewport. So, and it depends on the order and the distance between the object and the camera angle, and also based on what kind of tags that you use. So let's say you use a UI a tag for rendering an object using the overlay, right? So what will happen is that let's say you have rendered this quad as overlay. Okay, I'll just do it. I'll just paint it as yellow, right? And this is overlay tag, right? So even if there is an object behind this or ahead of this, basically, let's say there's a ground that is what will happen is that because of the overlay rendering tag, it will always render on top of this object. Think of it like a layer in Photoshop, and that's what the render tag does and rendering order does. So regardless of where you keep this quad, if it's in the frustum of the camera, it will always be rendered at the very top, basically. That's what all these tags do. If you are writing your custom engine, you could have called it whatever you want. You could have called, like in my custom engine, I call it as as UI or something like that. So it renders at the very last, basically, because what the GPU will do is that it will render this ground first, and then it will oh, I have an object called I have an object classified as overlay, and regardless of what happens, I'll render this one at the very end, basically. So that's how this shader tag especially works. So so right now it's set as render type and opaque, and LOD. Let's not worry about that right now. Your custom engine, I mean, my custom engine, as in I'm writing my own 2D like engine on the side as well, basically. So in that's what I meant, basically. What I mean to say is that these are all very Unity specific, these names, right? They are not like in Unreal, it will be called something else. In some other Godot, I believe it will be called something else. So these are not like uniform to all the different shader. Like for example, um, if you're using OpenGL, then this is the shader syntax that you'll be using, basically. But what Unity does is that Unity has its own language, and that's what we are using. And then under the hood, when you compile it and when you run the executable, it basically looks at what your system compatibility is. If it does not have a DirectX or a Vulkan, and if it falls back to OpenGL, which is what happens in Linux for the most part, because Linux for the most part uses OpenGL. So it'll just fall back to this shader, which is GLSL, right? So that's how that whole thing works. I mean, I'm sorry if it's a little bit confusing. I'm new to explaining these things, and if you guys are not able to understand, please let me know in the comments, and I'll try, or in the chat, and I'll try to be much better in explaining certain things, basically. Because a lot of things, what you're seeing over here is just syntax, basically. Like a lot of boilerplate, like all of this thing 90% of this is boilerplate basically. So pragma, vertex, vert. So this is basically literally copy pasting something that Unity wrote under the hood, and it's pasting over here when it's compiled basically. And that's the vertex information, right? Why is shade okay? Baswaraj is asking in the chat, why is shader languages not standardized? Essentially, all engines use standard library like OpenGL, Vulkan. So actually, it is standardized. I mean, standardized in the sense that so see these are the main. So essentially, the standard I'll tell you is wait, it's too bright. Wait, I'll just darken this. The current situation with regards to, and it's kind of annoying also, all these graphics programming, but I'll tell you the standard that we have right now. There's something called OpenGL. Oh, there's something called, oh my god, yeah, there's something called OpenGL, right? Which works in both Windows and Linux, right? And Windows itself has DirectX, and Linux has OpenGL only, right? And then you can use either OpenGL or Vulkan, basically. Now, OpenGL is least performant, I would say, and Vulkan is, when I say performant, if you know what you're doing, Vulkan is more verbose and more difficult to use, but more performant, basically, right? And DirectX is the most performant for Windows, basically. So this is primarily the situation that we have in Windows or in our ecosystem right now. And for the most part, DirectX is what, 95, I don't know exactly, but a huge proportion of consumers are using Windows, and DirectX is what is the best. And DirectX 12 is the most performant. It's even more performant in DirectX 11, but that's the most verbose. But best part about OpenGL is that you write it once and it works for both, basically. But OpenGL is the least performant out of all of this, basically. So that's the ecosystem right now. So hope, Baswaraj, that explains what you have. And it is standardized in many ways. Like Windows has DirectX and Linux has like OpenGL, and a lot of graphic cards support. And there is Metal for less cool. Oh, I completely forgot about Metal. Yeah, iOS and Apple have Metal, basically. So yeah, I completely forgot. Thanks, Graphy, for reminding me of that. But yeah, Metal is again something that Apple uses, and I know the there's a lot less people using Mac for gaming, but just mentioning. So yeah, this now is what is the situation, basically. And to be honest, I am okay with OpenGL, and okay with Unity's shader language. DirectX, I know high level. Vulkan, I know high level. I've never built an entire project in that. So that's my situation currently. But that being said, so where does Unity fit in? So Unity is in a unique spot, right? Unity right now is in a situation where they have to make sure that if you're the end user uses Windows, or if they use iOS, or if they use Linux, or if they use Windows without let's say support for DirectX. I'm just speaking hypothetically. It should support everything, and that's the power of using Unity, right? That's what you're paying, if you're paying Unity for, basically. The fallback or the disadvantage is that it is very much abstracted, so there is a cost for that abstraction. But the advantage that you gain is that you write it once and it runs everywhere, basically, and you just have to press the build button for the specific platform, right? And then obviously PlayStation, Nintendo, they have their own graphics situation as well. I completely forgot about that when it comes to console development. So some, like Nintendo, I believe supports Vulkan and DirectX, and I mean Nintendo Switch, and PlayStation have their own GPU pipeline, basically, that you'll have to learn, which is very similar to DirectX, basically. So there's other situation like that as well. But when it comes to Unity, so Unity has something called Shader Lab, which is a high level language which converts your language into whatever platform that you're using the game engine or you're deploying your build for, basically. So I hope that answered your question, Baswaraj. And Hiru, what are you making, brother? Well, the plan is to make a VFX, but this is kind of like an like my or this is like an intro to technical art and shaders. So currently I'm explaining how shaders work and where the whole like just an introduction to shader lab and Unity's shader language, basically. So pragma vertex vert is so I hope that my explanation um, in this page kind of gave you an idea of how uh, the standardization for graphics programming is, which is a little haywire. I mean, if you have worked on any project with graphics, you know how difficult it is to debug graphics. Like it's insane because generally the compilers don't support error and breakpoints in shaders, basically. So you have to debug it in a very verbose manner, which is kind of very annoying. But you have tools like, I forgot what is that called. I have that tool installed. uh, I forgot the name of the tool. You have some tools which you can use to debug, but still it's one of the most annoying thing to do, basically. So yeah, so coming back to Unity's shader lab, so the pragma word basically is what you would call what is that called? Yeah, 1 second. It's a it's basically in this case it's basically taking at the compile time it copy paste certain amount of code over here, basically, and that's what pragma is doing. It's basically a keyword that you're using so that you don't have to keep on writing the same thing again and again, basically. So there is a certain vertex code that Unity has written and pragma is taking that and then pasting it over here. And include Unity sieging again, it is just to make the fog work. So Unity has a certain math for making it work with the inbuilt fog system, which is over here in the lighting. So if you want to use this Unity's fog to work with this shader, you'll have to include that. I just removed that because we don't. I won't remove it right now, but we can remove it if we don't want fog, basically. And the app data is your vertex data. So we want to get the position of the vertex. So it is in this case. The other day you were coding, today you are doing, and you are an artist by profession. Why are you so? I made a Pong game using Love 2D. Ah, that's cool, man. I've never used Love 2D Hero. I don't. Is that like a? Is that like Raylib? Let me know what Love 2D is exactly. And Graphy says that why are you doing everything in this project? The other day you were coding gameplay features. Today you're doing technical art, and you're an artist by profession, right? Uh, I mean, we are an indie studio, so I take care of a lot of stuff. There's a team also that is working on the art, the 3D art, the animation, and the concept art. But I primarily right now I'm taking care of all the technical stuff, coding, design, business, and part of it is because I really love it. I enjoy working on all the different aspects. But if I ever feel down the line that it's too much, then I might hire someone, basically. So that's the situation right now for this project for Yodha, basically. That's the Yeah, it's the 2D framework for Lua. All right, all right. So that's what Love 2D is, basically. I've never used Lua also. I think it's a scripting language, right? Lua. It's, that's what but I don't know much about it. I generally code in C and C sharp for Unity, basically. All right. So going back. So what is app data? So app data is basically pulling information for whatever you want to draw. So right now we are saying, let me just do it like this. So this one, app data, we are creating a struct, or we are declaring a struct, and we are saying that we need position of the vertex and we need UV coordinate. The zeroth texture coordinate basically. You can pack, I believe, 10 texture coordinates right now, and this is basically the 0 means that it's taking the 0th texture coordinate basically. And this is basically what your custom engine in C. Yeah, I mean, when I say engine, it's not like something like Unity. It's just very simple. It's so I made a Pong game completely in C. I made a bunch of so I have a tool basically that I wrote in C. So this is like my this is completely written in C, and oh, I don't know whether you can see it, but yeah. So this is basically, I use Vim, and sometimes it's annoying. Like in Vim, there is a mode called command mode, which triggers when you press the caps lock key, right? So I made this tool to detect whether the caps lock is on or off, and it's written in C, and it's written in like directly using Win API basically. So these I write like small projects like this for myself to make different utilities. And with regards to engine, I don't know whether this will work right now, because when you need something, it'll never work. That's what I've realized. But I can show you a small. So yeah, so you can see this is one. Can you guys see? So this is one 2D game from scratch that I wrote. It has a physics. It has a physics system running behind it, which takes care of all the collision colliders and everything. And it's completely written in C. No library whatsoever except for STD image, which is basically a PNG decoder. But apart from that, everything is written from scratch directly using the Win API basically and OpenGL. So this is something that I do in my free time basically, and you can follow. So yeah, things like this basically. But that being said, all right. So going back to my, all right, just close this. All right. So yeah, so the struct v to f is basically vertex to fragment. So I'll just quickly also explain how shader pipeline works. So again, taking the example of the quad has different vertex, right? And it has UV basically. So here what we are stating is that this vertex has certain position and we want the UV information basically. So that means that this vertex, let's say it's in this kind of a coordinate system. This vertex is 0, 1, 2, 3. So it's like this. So and this is 0. So let's say it's in minus 0.5. This is 0.5. And this is 0.5, and this is 0.5. This is x, and in y also it's 0.5, 0.5. In x it's minus 0.5, minus 0.5, minus 0.5. Sorry. Oops. Yeah. So this is the position that we have for this quad, right? Which is what we are taking from here basically. And then there is texture coordinate. So texture coordinate is the UV coordinate basically. So each of this vertex is has a certain UV basically, right? And that is what. So this triangle has a UV, and this triangle has a UV basically. So that's what this is declaring over here. And now we are saying that we need to, this struct is used to send this vertex to fragment shader. So we have something called vertex shader and fragment shader, right? Vertex shader takes all this information in this struct and then gives it to fragment shader to paint things in your screen. Again, I am explaining this in a very, very high level, crappy manner. I'm sorry for that. But if you find this interesting, I can do another stream where I completely explain like how things move from vertex shader to fragment shader in a very detailed fashion, which has a lot of different uh, stages basically. So you have your vertex in your local space, it goes into world space, then it goes into clip space. So there's a lot of things happening. But if I blabber about all that right now, it's going to be out of topic basically, and you might get bored also. So I am kind of explaining all this in a very simple manner, right? So coming back to the topic, so vertex shader tells the fragment shader, brother, we have these vertices at these point, at these UVs, and I want to paint these pixels onto the screen in these areas. So let's say we have a texture, all right? We have a texture of this smiley face, and this texture is 512 by 512. So our vertex shader tells the fragment shader, boss, this quad is in the 0.5 in this coordinate, and these are the UVs, and I want to paint in these UVs these pixels. So what it will do is that it will go in this fashion. Let's say this is that chord, and it will fill these pixels basically with this texture, right? Now, if you would have done this in CPU, and you can do this in CPU as well, it will happen, or it will render in an array fashion basically. Like it will go row by row or column by column based on how you write your render loop. So you can do it like, okay, so let's say there are different colors over here in this texture, right? You can take this copied one pixel at a time like this. Now this is going to take a lot of time if you do it in CPU. The power of GPU is that all these pixels will be filled together in one frame, basically in one loop. And that's why we have your graphic card, because it has many cores, it can run things parallelly. And that's what your fragment shader does. It basically tells uh, your graphic card to take all these pixels and paint them or splat them instantly basically. And again, instantly, all these are like high level words that I'm using. There's performance cost to everything, but it's much more faster than in the old times basically, like back in the Prince of Persia days, or back when we did not have graphic cards. This would be done in CPU, and we can do this now also. Like I have written a render loop in CPU as well. With the current CPU that we have, you won't even feel like there would be much slowdown in your system. But graphic cards is significantly, like a lot more faster than CPU, right? In doing this task, basically, in doing parallel task. So that's high level, explanation of how that. So basically, your vertex shader um, sends to your fragment shader. That's how that works basically. So here in the V2F, we are taking the UV and we are taking the position. So this is the SV position. I don't exactly know what SV position means. Again, it's Unity's own keyword, but all I know is that these vertexes are, you have your custom transform right over here basically, like X, and so you can push the vertices where you want. So these this quad that we built, it has its own local space position, which is your 0.5. It can be whatever, however they have initialized it. We don't have power on that. But then what Unity does is that then the user can assign their own position as well, and it'll add to that. So let's say I add one X and one Y and one Z, right? So what will happen in the shader is that onto this one will be added to its X and Y, and that's what you are seeing on the screen basically in clip space. So that is what I believe this is doing. So it's taking the local vertex position and then it's painting it, taking the position to paint it on the screen. And these, what you see over here, are your variables basically that you will use in your shader. So the main, and this should exactly match with what you have declared over here. So if you want to use any this main text, you have to again declare it over here. And sampler 2D is, this is again something, the data type is graphic oriented basically, in the sense that OpenGL uses sampler 2D for anything. If you have a texture, you have to use sampler 2D. It's like int, it's like float. Sampler 2D has pixels in it basically. And for the main text st, again, this is very Unity centric keyword. What this means is that if you want to use these variables, the tiling and the offset, right, you have to use the main text st basically. That's just what Unity says. So we have to shut up and we have to use it. There's no explanation for that. You have to read the documentation. if you want to use this basically, right? And okay, so now these what I've highlighted over here is the actual meat of what a shader is, right? Rest everything else is more of like boilerplate, and it's not boilerplate. You can do a lot of stuff with that as well, but in this context, mostly all of them is the boilerplate basically. Hiru 379 says 3D is hard. 3D is hard. Yeah, everything is hard, man, in many ways basically. Like making games is extremely difficult, but I understand what you mean. Like 3D is hard. Like graphics programming is hard basically. 2D is relatively simpler than 3D, but if you, I think it's hard if you don't know what is happening under the hood. I believe if you learn how memory works, and how computers work at base level, and then you go to 3D and graphics, it becomes much more easier for you to understand what is happening under the hood. But that being said, coming back to the point basically, this isn't just a 3D thing. 2D works the same way under the hood. Exactly what Rafi is saying. So um, anyway, so this is your vertex code for your shader, and this is your fragment code. So the in the vertex code, what we are doing is that you remember this struct that you have declared of the app data, and v. So generally, you can name this vert whatever you want, but you have to make sure that it matches with whatever you're declaring over here. But this is the template that we use. So here we are using a v2f, right? A vert v2f, it returns, and in the fragment we are converting this into the fragment basically. I did not explain that very well, but let me give me another chance basically. So what we are declaring over here is a v2f struct, right, with a uv and vertex, and we are calling it o. Okay, you can call it whatever you want. You can call it anything, like whatever you want. And then in the vertex data of this v2f, we are taking the unity object.clipPose. So this is again a keyword that Unity has given us. And what it essentially does is that it takes this clip position data, the data from this transform basically, and then it attaches to the vertex basically. You can see that the vertex v.vertex, right? The app data from here, this vertex variable, it's taking the clip pokes and it's converting and it's infusing it into the v2f data basically. And then same in the uv, we are taking the transform.text, we are taking the uv and the main texture basically inside this uv basically. So that's what we are doing over here. This we don't need right now. So and then we are returning the object, the v2f struct basically over here. And then in the fragment shader, we are declaring a variable called I, v2f I, and then we are, so this I is basically I don't know how to explain. I kind of suck at explaining. I'm sorry, guys. But this v2f is actually the returned O over here, right? And then it is assigning the color to it, which is the texture 2D, the main texture. And then again, we don't need the fog, and it's returning the color basically. Trust me, it'll understand. You will understand this eventually. But so let me explain that again, right? Using the, let's delete all this nonsense and let me explain that again. Okay. So what we are doing over here, right? This vert here, we are creating a v2f struct. We are creating an object for the v2f basically, right? So let's call this v2f, right? O is not an object, it's an out. I is in. Yeah, exactly. I mean, I don't know what to call it, man. Like it's some data basically is what I meant, not an object. But since most people are, into object-oriented programming and all, like that's how I can explain basically, because things are so abstracted. Technically, this is your vertex data, and then it's being sent to the fragment shader. So I just used. Please don't. Please ignore the kind of terms that I'm using, just understand that there's some V2F data that we are creating, a struct that we are creating called O, and in this object we need the vertex position and the UV information, right? And where do we get that from? We need to get that from the vertex data of the object. So for example, if we are assigning the material to this chord over here, we are getting the vertex from here and we are assigning it into this V2F basically. So here you can see that Unity object clip to pose V vertex, and it's getting us that vertex information, and the UV is getting our texture information basically. Not texture information, sorry, the UV information basically. And once we get this, we are then sending it to the fragment shader, and we are saying text2d is a syntax basically to fetch the texture information, right? A main text, we are basically assigning the color. We are getting the color from the main texture, and we are passing the UV of this V2F, and then we are returning the color. Now uh, let me show this in a practical manner. So let's say I want a red color to be exposed, like regardless of the texture, I want to multiply it with red color. So let's do that. So let's expose a main color, right? And let's call it color. And I believe color is equal to, wait, I forgot the syntax for this. Wait. Where is that color? Yeah, main color. So this is the syntax for exposing the color property, right? So let's do that. Color is equal to default will be just white. So it's RGB, right? So now if you see over here, you have the color, this thing basically. Now what we want to do is that we want to multiply this red with whatever texture we want over here. So let's assign a texture. Let's make a smiley face. Let's just quickly make a texture so that you guys can understand what I'm talking about. And if you don't understand, it's not your fault, it's my fault, because I am absolutely horrible at explaining things. Smiley face. And I'm not prepared, to be honest, basically, for explaining. But that's the situation. Okay, so we have this smiley face, right? We drag and drop this smiley face over here and we assign it. So you can see now, you can see the smiley face, because what are we saying over here? We want this main texture and the UV basic, which UV of the chord, which we got it from this line, right? But we want to multiply this red color to this smiley face as well, right? And we exposed a new property called main color. And now, how are we going to multiply it? We want to multiply it over here, because fragment shader is the place where you can multiply this basically. Fragment is again the pixel information, vertex is your vertex information basically. So I'll declare float. A fixed 4 should be enough. Again, you have different data types. Float 4 is the most expensive, I believe. Fixed 4 is less precise. It's a less precision version of float 4, but I think it should work for our color. And then I'm going to use main color, and then I'm going to multiply this color into main color. Let's see if it works. So now you can see we can change the color now. So we can change this. So this is basically a very basic way to create a shader basically, right? So we have created a color, exposed the color property, and now let's say you want only 50% of red. You want to expose it so that when you press a button or in the game, you want the color to what do you mean by precision? Float, 32-bit float has a certain precision, and like if you, let's say you're writing in C or C sharp, your float 32 has less precision than float 64. So if you want a high precision, like if you want to build a high frequency clock, or a, which has like a lot of decimals, then you would use a float 64, right? Otherwise you can use a float 32 basically. So that's, but in places where you don't want that high of a precision, you can optimize your code, and that's where fixed 4 comes into picture basically. So we don't need that high of a precision for main color, because each color itself is 255, like 255, 255, 255, 255. So we don't have to use that much precision basically. But in the vertex or in the main texture, we can't do this basically, because we need, certain areas, like for example, if you want to expose the vertex position or something like that, you would not want to. And if you want like precise, like very accurate position, then you should use, float 4. But for the most part, fixed 4 should work basically. So that's what I meant by precision. So let's say now you want to expose this variable where you can change the strength of the color. So let's do color strength, and called color strength. We'll use a float for this, right? No, we'll give me a moment. Float, and or we can use a range from 0 to 1, and the default will be 1. Let's see if we have this exposed now. So we have a range now, right? And if it's 0, it will default to the texture color. If it's 1, it will be fully red, and that's what we want to do. So we will come here, we call float color strength, and then all you have to do now is, again, we can declare a new color called final main color, and we'll multiply the main color into color strength, and then we'll multiply this to final main color. All right, and now let me see if this works. Now you can see. Okay, so now what is happening is that the color strength is this. When it's 0, it's multiplying with the color and it's completely turning it into black basically. That is why this problem is happening, right? So how can we fix that? Strength, we are multiplying it completely over here. Second, right. Oh, instead of doing this, we can use lerp. So what we'll do is that instead of multiplying the strength color for general views, but I'm sucker for these things. To be honest, this feels too advanced for a YouTube live stream. General viewers, but I don't think so. I think, see, that's what I also felt. But what happens is that I hope that many of you who have joined the stream, you won't be able to understand all this thing. But what happens is that you get exposed to all the things that I'm talking right now, and I might not be 100% accurate, but you can then go back, do your own research, and understand that it's not rocket science. And then if you start working in this and start tinkering in this, then eventually you will get the hang of it. It's not that difficult, right? The problem is that for me at least, when I was starting out in this, I did not even know where to start in because I did not have a computer science background, right? So I had to go through Casey Moratories, and I would recommend all of you also to look at Handmade Hero and all these tutorials that you have in YouTube, which are low level tutorials, to get a hang of all these things, because it really helps in Unity and Unreal as well. Basically, if you know how the low level systems work, and even if you are using AI or whatever tools that you're using, if you have an underlying idea of how things work from at the very low level, you are much more better off using all these tools basically. So I'm going to use lerp. Lerp, is an inbuilt. There is an inbuilt function for lerping, or you can write your own as well. Well, why do it when you have lerp? And I hope everyone knows how lerp works basically. So we're going to lerp between um, color to main color. Sorry, yeah, main color and the color string. And yeah, now let's just do return the final main color. Let's see if this works. So now we have this kind of a situation where if we do this, it's going to completely change into red, and if I go back, it will change into white basically. So again, you can do all sorts of different stuff um, based on whatever your requirements are. So I just wanted to, so the whole point is like I'm going to use the amplify shader editor basically, and I'm going to quickly show you how quick, like this is quite verbose, right? You have to write all this thing, and then it takes time to see it in real time what is happening. But amplify shader kind of helps you speeden up the process basically. But I would still suggest all of you to just write shader from scratch as well, so that you get a sense of like how things work. Because what we do inside the studio, or when we work in our games, is that we actually build in amplify shader editor, then we eventually copy whatever we have done in amplify shader editor and write our own shader code basically. Because amplify shader editor is not that optimized, right? So for example, we have like precise uh, data types that we can use over here, but amplify would create its own data types, and it might be unoptimized. Certain algorithms that you would connect through nodes would not be that optimized, so we can unwind that over here. So amplify shader editor, I'm using it because it's for convenience sakes, not because I can't write my own shader using a shader lab basically. But that being said, um, I hope this kind of gives you, a basic understanding of how shaders work. So let's move to amplify shader editor now, and let's do this same thing in amplify shader editor, and let's see how fast it is, right? So let me pull up the amplify shader editor tool. So this is amplify shader editor, right? So the shader tag is over here. So transparent. This is basically stating will convert this render type to transparent. That's what this is doing. If you want, I can make it opaque as well. Geometry. So I'll just take a color, a float 5, so RGBA. I'm going to connect it to albedo. I'm going to take a main texture 2, and then I'm going to multiply this, connect this. I'm going to call this color. Boom. Change this into property. Boom. Change this into texture. Boom. Albedo. And now if you see over here, see, I have the color, I have the main texture, and I'm going to drag this. So right now I'm going to put this, and you can see if I change this into red, same thing is happening over here, right? So this is how fast it is for me to write. So you can see a lot of boilerplate thingy has gone away over here, uh, you know. But it's good for, like, for me it's like if I want to, let's say, optimize this code, I can just go. So Amplify Shader Editor, the good thing about it is that I can actually open that Amplify Shader Editor code in a text format as well. So you can see, uh, the code here, and then I can optimize it if I want to, basically, because I know how Shader Lab works. But it's essentially doing the same thing that we were doing in our um, code, basically. If you compare them both, right? So that's what it is. And there's a lot of different things that you can do called swizzling. And if you want to change the R channel to B channel and B channel to, you can do texture compression and a lot of different stuff, but let's not do that right now. We have like 20 minutes right now. If you have any questions, with regards to resources or anything like that, please let me know. I'm going to close the stream at 9:30, but I'll quickly try to make one VFX with a panning shader. So the idea is to, within 20 minutes, make a panning shader which kind of looks like flames, right? So and if you have any questions, please let me know in the chat. In the meantime, and also if things are getting too confusing, please let me know. Please give me constructive criticism so that I can prepare for the next stream in a better fashion, basically. And if this is not interesting, please let me know that as well, so that and if you find this all boring and you want me to switch the subject, I can do that as well. So let's make a flame shader, which was our original goal, right? So how are we going to do this? So we need a transparent shader. So I'm going to convert it into transparent and transparent. So now I believe we'll have a transparent shader. So how do we? Nation demands flame. So let's quickly test if our shader is transparent. So what is transparent shader? Oh man, there's so many things, interesting things actually, that needs to be covered, like how transparency works. And it's so simple actually. Like once you understand how transparency works under the hood, it's like super interesting, like how things work. So generally for transparency, as many of you might know, we use alpha, right? So in this case, we are going to make anything which is black transparent, basically. And so there are two ways that we can do that. We can use an additive shader or a multiplied, what do you call that, alpha multiplied shader, basically. So the additive shader, we can simply use the R channel of the texture to mm, discard the pixels and make it transparent, or we can use the alpha technique, basically. So I'm going to use this mask right now, just to test. So let's do that. And then let me just bring it over here. And let me just glow alpha flame. Okay, so right now we want a yellow flame, right? Okay, so let's put this into the opacity shader, and then let's put the RGB to emission shader. Boom. And let's multiply it by color. Multiply the RGB goes to emission. Yellow, alpha full. So now if I expose this and if I expose the color, so now you can see that we have a yellow transparent ball, and we are using an optimized way to for transparency, which is not using the alpha itself, but using the R channel, the red channel, which is all the blacks that you see over here, and we are plugging it into the opacity, and we are saying that wherever in this texture there is black, discard it and don't show it to us, basically. So that's what we are doing, and we are discarding the pixels, basically, for transparency. Okay, so now What do we need? We need to, so the technique that we'll use is that we'll distort this UV quickly, and the way we can um, distort the the texture is by distorting the UV. So you can see that we have this UV node. So let's add a panner. And let's do a UV coordinate. Let's add, give me a moment. How can we do this? Coordinate. Okay, so that's not how we'll do it. We'll add a panner. Texture sampler, and we will use this to distort. We'll use a noise texture. We'll use a Perlin noise, and we'll use very lightly. Show. How come the addition? UV. Okay. Let's do a different technique. Let's not do this one because we don't have time to do it like this. So we'll use directly the noise shader to the opacity. We'll use the emission. Color. And then we are going to use the alpha for this. Oh, sorry. Red channel for this. All right. And then we use a step shader. So we are going to use a step. And then we are going to use a flame which is going up. We'll multiply this one. Yep. All right, and then we can use something like this. This is just a quick test. Make sure that we have something up and running quickly. Right. Then what we are going to use is a gradient. Actually, this is not it's not refreshing very nicely, so I'm just going to play so that this thing refreshes in a much better way. Yeah, like this, in a better way. And next, what I'm going to do is that use just want to call this gradient, and use the gradient over here. 0.5, 0.25, no, 0.5 and 0.5 should be good. And we are going to expose the panning speed. So that, let's call this pan speed. I'm going to expose that and call it 0.5. All right. Next. We want some kind of a gradient, right? So let's create another texture, and we can multiply it to our step, and then we can make a gradient. Let's use a bottom to top gradient. Let's see how that goes. So now we have this kind of a gradient, right? And later we'll convert this what do you call it, convert this quad into a cylindrical mesh, but we don't have time for that right now. So I'm just going to quickly convert this into a point light, just so that there is some light here. This thing. And also we can do, what we can do is that just finished my 6-month internship as a Unity game programmer. I want to move into graphics optimization and real-time rendering. I'm a third year BTech student and want real industry experience, not just portfolio projects. I am a third year BTech student and want real industry experience, not just portfolio projects. Any tips? Well, you need to have a good portfolio project to get into a good internship so that you can have real industry experience. That's one way to go about doing it, is have a portfolio which is very close to what a real industry product would look like. So for example, and if you're into graphics programming, um, and if that's the kind of job that you want to do full time, then your portfolio should kind of reflect that. So making a 2D renderer or a 3D renderer, making a text editor in OpenGL, Vulkan, and DirectX, that kind of strong portfolio is in fact needed, and so that you can get that real industry experience that you're looking for. The question is that where do you want to work, basically, to do, where do you aspire to work when you're talking about graphics optimization and real-time rendering. Do you want to work in a AAA environment, because that's where, like, most of the big companies right now are using Unreal and Unity. They're hardly, I believe Blizzard uses their own engine. I believe Rockstar uses their own engine. There are certain companies that use their own engine, or you can completely move into Autodesk or Adobe and all these software companies where they do real time um, rendering and you know graphics intensive work, basically. So it all depends on where you aspire to be. But when you say that you just don't want to build portfolio projects at this age and time where you are in right now, you have to build a very strong portfolio, and those portfolios have to kind of show the end product. I would say they should not be just small tools when you eventually pass out, or when you eventually are going for these jobs. That is the strongest candidate, I believe. That being said, let me just quickly God. All right, let's duplicate this, and let's multiply it again. Oh, no, sorry. Not the most optimized way, but we should still. And we'll multiply both of this now, so we should get, and we'll get this kind of no, that's not the right. Let's convert the mask a little bit. Convert it into something like this. And we'll improve this as we move ahead. What are your thoughts on Nvidia or game? Don't get influenced by game part. What are your thoughts on? Give me a moment. Huh? Let me just. Oh no 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 no. If we don't use step, by the way, this is how it will look, which is not the kind of style that we want. So we'll use step again, and we will most probably also use gradient 2, and this is gradient 1. Give me one moment, guys. Let me just, because I'm running out of time, I just want to get something up and running today, and then we can polish it and do all the beautiful stuff later. So this one we can have like this. Two. We can even expose the step 01 property, step 02 property. Oh, 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 oh. 0.75. What? Where is step 02 property? Okay, this is, I believe, give me a moment. Let's put some, let's make the color HDRI. Where is the HDRI property? I forgot. HDRI कैसे करते थे यार? Huh? What is happening? Custom ad. Where is the HDRI? There was a way to do HDRI over here, right? Huh? Where is the HDR option? Am I missing something? What is happening? What is happening? Oh, give me a moment, guys. How is the stream going? I've not been seeing the stream. Okay, Graphy says, what are your thoughts on NVIDIA AMD jobs versus game graphics programmer jobs? Don't get influenced by games part for the second. I think it totally, I mean, NVIDIA AMD jobs are, um, they both are completely different, what do you call it? Applications of graphics, right? Like the AMD job, the requirements are completely different. You'll be working at much more lower level and looking at the graphics chip side of things and the graphics card side of things. Whereas graphics programmer in games, the responsibilities are completely different, and the skill sets, the applications are completely different. I believe basically. In today's industry, graphic programmers are expensive for studios and they don't always need them, so the roles can be more prone to layoffs. Don't you think? Layoffs, don't you think? Totally depends on. So, for example, a company like Blizzard, they already have so much banking on their, like, for example, StarCraft. They already have built a StarCraft engine, which is basically an expansion of the Warcraft 3 engine. So, I don't think so. They'll completely they won't be able to. I don't believe they can transfer that into Unreal Engine or something like that, because all a lot of things are dependent on that. So for legacy reasons, I don't think a lot of the old school guys will change to Unreal, but you never know. For example, Witcher, I think the new Witcher is completely being made in the new Unreal Engine or something like that, even though they had their own engine in the past. So it's not really sure. Again, I don't believe you should, again, this is my personal opinion. I don't think so. You should look at the prospects and then choose your uh, what do you call it? Your stream, your professional um, department. I think it should be more about your passion, like what you are really passionate about. Because what will happen is that if you're passionate about something, you will be the cream of the crop, and you will always be looked after by the company because you're so good at it. So that's how I have built a career for myself, and so I've always followed what I truly believe is something that I'm very much interested in, and by hook or crook, I have landed with amazing jobs and good prospects for myself. There have been difficult times for me, like everyone else, but for the most part, it has worked out very well. So that's my take on that. I hope. But that being said, I was wondering why. How come? Oh, this one has, but this one does not have. I don't know. Look, they both are the same. This thing. Look at the bug. You have all these attributes over here, but here you only have one attribute. I don't know why. Anyways. Oh, I think it's because colors. No, I don't know. Some bug. But anyways, now I have the color. So I'm going to do this. I'm going to enable HDR. And this can be the color, flame color. Okay. We can make smoke and everything a bit late. Like in the next stream, we can do all the other stuff as well, like really polish it, and we can make a better mask for this. Eventually, so that'll be the plan for the next this thing, and we can also, yeah, exactly. That's true. That's true. And we can quickly add some post processing. Post processing volume. Post processing. Let's just use battle right now and align with view. And why is the color grading so bad over here? Solid color. Let's just use black. Scenes. Development or stream. Flame. And why is the color so horrible? Why is the color so horrendous? Is it because of the directional light? And let's do a night scene for now, just a test. Let's do a point light. In the next stream, it'll be less theory and more application, and we'll improve this flame to have like distortion. And so right now it's just, and we'll make a custom mesh as well, which will properly, like right now I don't have control over how this flame goes, but we have the base there right now, and then with the smoke and everything it should look good. So we have this, and in fact we can turn the shadows in this thing to a shadow here. Oops, that looks ugly. Change this to a yellow shader. So yeah guys, so that's it for this stream. Why isn't the why isn't this thing working? Let me just why isn't the texture sampler working? Give me one moment. Okay. I think this is better, yeah? No, this is not better. We can create our own gradient slider also. I think that will be better. Basically. And we'll also work on a way to make sure that when the mesh collides with another mesh, it automatically smoothly fades out. We can do that as well. So right now we have the base running, base working. So in the next, so right now it's not looking that good because we don't have distortion for this texture. So we'll take the UV channel and we'll distort this texture as well. That's where we'll get the whole flame kind of a feel, and we'll use our own mesh, which will be like a flame shaped mesh, and then we'll run this shader on that as well, and then eventually we'll do some code for the light so that the intensity increases and decreases, and we have this kind of a flickering with some smoke and particle effects and things like that. So that is our stream for today, and I hope you guys enjoyed or at least learned 2 cents from what I had to blabber. All right. Is there any questions that you have? I'll be closing the stream in 1 minute. All right, then, guys. Thank you so much for joining the stream, and I'll see you next week. I'll plan when I'll stream next week, this weekend. So, and also please join our Discord if you haven't. It's at the rate Ogre Head Studio. I can share the link for the Discord here. Invite to server, copy. Uh, if you haven't already, please join our Discord. The link is there. So, thank you so much. Good night. And yeah, see you next time.